All right, so these are the answers to the review. Kind of wrote it all out just to make it hopefully a little bit quicker of a video. I'm just gonna go through it here, okay? So, first things first, I would try to factor at all times right in the beginning. I think it helps you out. When we factor the top, we look at factors of negative 32 that add up to positive 8. That would be 8 and negative 4. On the bottom, factors of positive 4 that add up to negative 5 would give you negative 1 and negative 4. Okay, the x minus 4 and the x minus 4 will cancel out, and that'll tell us something as we move along. So, y-intercept, we're going to set x equal to 0. If we set x equal to 0, we will get negative 8 in this function. That means that your y-intercept is 0, negative 8. You have to write 0, negative 8 on the quiz. If you just write negative 8, you will get points off. X-intercept, we're going to set the function equal to 0. Back from algebra 1, you would set the y value equal to 0 to find the x-intercept. So if we do that, we would have, and again, this is one of the reasons why factoring is helpful. I just have the x plus 8 over x minus 1 there, set it equal to 0, and cross multiply. If you cross multiply, you want to put the 0 over 1 so that you're able to cross multiply, and that would give you 0 equals x plus 8, right? What would give you 0 here? That would be x equaling negative 8. So my x-intercept is negative 8 comma 0. Again, that's how you have to write your x-intercepts, or you will get points off. Okay, so that's my x and y intercept. My horizontal asymptote, I am going to look for the degree of the numerator and the denominator. Okay, the degree of the numerator over the denominator. If I'm looking at my original function, right, the degree on the top is 2. The degree on the bottom is also 2. So if they are both the same on the top and the bottom, what we're going to do is take the coefficients and divide them. Once we divide the coefficients, that will give us our horizontal asymptote. So what are my coefficients of x squared and x squared? Well, that's just 1 over 1, right? So my horizontal asymptote is y equals 1. For the vertical asymptote, what x value gives me 0 in the bottom of my function? Again, one of the nice things about factoring this guy is that we are just left with x plus 8 over x minus 1. Right? That's what I'm looking at, x plus 8 over x minus 1. What x value would give you 0? Well, that would be a positive 1. Right? So my vertical asymptote is x equals 1. If I'm going too fast or if it's kind of annoying with all the shaking, you can obviously always pause the video and go back. But again, I'm just trying to make this as quick as possible. Your hole, is there a hole in the graph? Okay, what the hole in the graph is a point in the graph at which there's a break in the line. The reason there's a break in the line is because when we cancel out binomials, all right, and that's why I kind of did it in green here. When I cancel out these binomials, all right, our reduced function is x plus 8 over x minus 1. However, okay, we can't really forget about what we canceled out, because in the original function, okay, if we had more time in class and everything, what you would find is that if I put a positive 4 in to the original equation, what you would end up doing is dividing by 0. If that doesn't make sense, if we look at this before we cancel out the x minus 4, right, because again, it's not canceled out in the original problem, if I put a positive 4 here, I would get 0 on the bottom of the fraction. I would get 0 times 3 on the bottom. If I put 4 in for both x's on the bottom of the fraction, I would get 0 times 3, which is 0, meaning I'd be dividing by 0, which means, right, it's undefined. That's why when you graph this in your graphing calculator, it gives you an error at x equaling 4. That's why, all right? But anyway, algebraically, the things that cancel out give us the x value of our hole, right? So I know that my x equaling 4 will be my hole. And then how do I find my y value of my hole? I'm going to put that x into the function, which is what I did right here. But if I go back to here, right, if I put 4 into this function, right, I would get a 0 on the bottom of the fraction. So what you have to do is you put 0 into the reduced function, right? That's what I did here. I put 4 into the simplified function. If I put 4 into the simplified function, I get 12 over 3, which gives me 4. That's my y value of my whole. Okay, so my whole is at 4, 4. Now what you're going to do is you're going to fill in what you know, right? And before you draw, I would check it with your graphing calculator or Desmos. All right, so again, what do we know? We know the vertical asymptote at 1. We know the horizontal asymptote also at 1. We know the x-intercept. We know the y-intercept. Okay, we know those 4 things. The other thing we know is our hole, right? We can put our hole in our graph. It is a break that's going to happen in our graph. So the other thing is, 1, the graphing calculator will help you trace your line, and 2, it might give you some other points. What I mean by other points is that from your graphing calculator, if you put this in the graphing calculator, you would see on your table 2, 10, and 10, 2 being points on this graph, all right? You see a bunch of other points that will be decimals, and it's really hard to graph those decimals. So really all I'm looking for is that your line looks similar to what I have here. On the quiz, I'll be looking and making sure that you made an attempt to make it look like a function like this, okay? Now that that's all graphed, the last thing we have to do is find domain and range. Domain is all my x values. So that means if I start out here, right, at negative infinity, pretend that yellow line's going on forever, right? Negative infinity, I got x values, right? I go along the line, I still got x values, still got x values, still got x values, until this black dotted line, right? That's your break in your x values. You can't have the x value equaling 1, or else that would make us divide by 0 in the function. So that means that there is a break, okay? There's a break in my x value being 1. That's why I have negative infinity to 1, union 1, right? And then, you know, we're going to keep going. This 4 is happening because as we move along this yellow line, right, we're moving along, right? This is y equaling 2, and y equaling 2 is right here, right? Move along the yellow line. There's a break again if x equals 4, right? Because that's our whole. So that's why I have another break in my domain, right, at 4. After we get past the whole, right, the yellow line just continues all the way to the right out into infinity. So again, my domain would be negative infinity, comma 1, union 1, comma 4, union 4, comma infinity. My range, what I'm going to do is I'm going to start at the bottom of my graph, right, because this is down at negative infinity. So this yellow line's continuing all the way down to negative infinity. So we travel up our line, right? We're good. There's still y values until, right, we get to our horizontal asymptote, which is at 1, right? That's going to be our break in our line horizontally. So I have negative infinity to 1, union 1, and what you see is that after the horizontal asymptote, you have another y value that you're not allowed to have, which is 4, all right? It is a coincidence that they're both 4, and that's why I try to use the colors to not confuse you. But your range, right, is going from negative infinity all the way up to your horizontal asymptote at 1, then from 1 to your whole at 4, and then from your 4 all the way up, right, and then this yellow line's going all the way up to infinity. So your range should look like that. Okay, just one last thing. It is a coincidence that the domain and range are the same. All right, that won't always happen. It's just for this one, it's, you know, just by chance here. All right, next one. It's a simpler function, but we're going to do the same process. Let's figure out the y-intercept by putting 0 in for x. That gives me a y-intercept of 0, 1. And again, that's how you're going to have to write it for the quiz. For your x-intercept, you're going to set the function equal to 0, right? Cross multiply, you get x equals 2. That means that your x-intercept is 2, 0. Your horizontal asymptote, right? If we're looking at my function, what's the degree on the top and the bottom of the function? The degree is 1, right? The exponent of your variable. So it's not written there, but it is a 1, right? So I can write in there real quick, right? It is a 1 for both the top and the bottom, which means if they're both the same degree, if they're both the same degree of 1, right, we're going to do the coefficient divided by the coefficient. Coefficient of the top is 2. Coefficient of the bottom is a 1, right? So 2 divided by 1 is a 2, which means my horizontal asymptote is 2. Okay. Vertical asymptote, right? What gives you x in the denominator? That one's a little easier, right? That would just give you, that would just be what x value gives you 0 down here. That would be a positive 4. Whole, there is no whole, right? Because there is nothing that cancels out. So there, you would write none if they asked you if there was a whole. Now, let's try to graph what we know. So my horizontal asymptote, my vertical asymptote, my x and y intercept here, right? X intercept being 2, y intercept being 1. Now, again, what I would do is I would use the graphing calculator to find some more points. Okay, I used my graphing calculator to find these 4 additional points, and again, that's just to help me graph what's going on here. All right, make sure as you're tracing your line, you do not cross the vertical or the horizontal asymptote. If you do, that will be points off on the quiz. Okay, domain and range, again, just like from before, we have breaks in our domain at our vertical and horizontal asymptote. What's nice about this domain and range is that there is no hole in the graph, which means we don't have to account for more breaks. All right, there's only 1 break in the domain and 1 break in the range for your horizontal and your vertical asymptote. Okay, so that is all. All right, so hopefully you guys can watch this before you take the quiz. Good luck, and again, you can always just email me if you have any questions.